Hi, my name is Anetta, and if you don't know me yet, go ahead and visit my blog. I left the links in the description box below. What I do is explain all the topics in the AS chemistry. I post new topics every week along with past paper questions that we are answering on the YouTube channel. If you have any questions, please just ask them. You can do it via my email, which I leave in the description box, or through my blog page. There's loads of space on the main page where you can write a message to me. And in today's video, we're gonna have a look at the electronic structure and ionization energies. If you're not familiar with the topic yet or feel unsure about the topic, I try to explain everything I know about ionization energies and electronic structures on my blog post. So the first question says, write the first ionization energy of aluminium. So what you do is, you don't actually need a periodic table for this. You have aluminium with first ionization energy, which means it lost an electron already, so it's positive. First ionization energy means first loss of an electron, which just flows. It always has to be in gaseous state. And just to balance the equation, this means we have to have aluminium on this side. What you realize that when the question asks you about the first ionization energy, you put 1 plus on the right hand side. If it would ask you about the third ionization energy, for example, you would write aluminium 3 plus, of course with gaseous state, plus 3 electrons minus. No, plus electron minus. So whatever ionization energy they ask for, you put it on the right hand side. And then you just balance the equation like this. So this is an example of what I was saying. So we have to write the sixth ionization energy of zinc. So in the products we write 6 plus, because that's what we're trying to find, and in gaseous state, plus the electron minus. And then to balance the equation, you have to do zinc 5 plus in gaseous state as well. So you've got 6 plus minus 1, which is plus 5, and plus 5 on the other side. So whatever you're trying to find, just put that on the right hand side and then work around this. The next question I've prepared for you says the electronic structures of 5 atoms are listed below. Arrange these atoms in order of increasing molar first ionization energy. So what you've got here are 5 electronic structures of 5 different atoms. We've got to find which one will have the lowest first ionization energy. In this example, I would say C, and this is because they all have half full shell or a full shell, but not C. D and E are bigger than C, which means they have much greater attraction from the nucleus because there are more protons in them. A and B, however, have a greater first ionization energy than C because A and B have less shielding, which means C have the smallest first ionization energy. So we can cross him out already. The next one as you can see, they would all have 2 shells. 1, 2. Because this one has 4 electrons, so it will look like that. And even though E has 8 electrons, it will still have 2 shells. This means they both have the same amount of shielding. However, D and E have still more attractions from the inside because they're bigger. They have more electrons, meaning they have more protons. So the attraction from the nucleus is greater than for B. Therefore, our next atom would be B. We've got next is A, D and E. As you can see, A has the least amount of shielding. It will hold the electrons very closely. Therefore, we can straight away put A as the strongest first ionization energy. This leaves us with D and E. And when you have a look at them, they both have the same amount of shells. So they both have the same shielding effect. However, this one still has a greater attraction from the nucleus. Furthermore, as you can see, it has 8 electrons, so it has a full shell, so it would be difficult to take an electron out of the full shell. Therefore, this is the order of the first ionization energies. Okay, the next part says, state given a reason which one gives the first 4 ionization energies for silicon. And for this question, you will need a periodic table because you've got to have a look where silicon is. And we've got it right here. It's in the 4th group, which means it has 4 outer electrons. So after the first 4 ionization energies, the 5th ionization energy would be removing electron from a full shell with less shielding and greater attraction from the nucleus. What we've got here in A shows us that the biggest jump is between first and second ionization energy, which doesn't apply for silicon. That will be his first to second ionization energy. It's easy for silicon to lose that electron. It will be the most difficult. That will be the first ionization energy, second, third, fourth, and the 5th ionization energy would be the one that will have the highest jump. So we've got to have a look at B. The biggest jump is between 3rd and 4th. That's not good for us. C, the biggest jump is between 2nd and 3rd. That's not good for us either. And in D, there are no big jumps up here. If we have the 5th table, that number would go massively up. This means the highest ionization energy would be between ionization energy 4 and ionization energy 5, which applies to our silicon. That's why D is the correct answer. And next question, hydrogen has a first ionization energy of 1312 kilojoules per mole. Explain why helium has a higher first ionization energy than hydrogen. As you can see, both helium and hydrogen have only one shell. So helium and hydrogen have the same amount of shielding. So this is not a reason why helium has a higher first ionization energy than hydrogen. The reason is helium has 2 electrons and therefore 2 protons, and hydrogen has only 1 proton and 1 electron. So that there's greater nuclear charge for helium. The next bit says, sodium and potassium are both in group 1. Explain when sodium has a higher first ionization energy than potassium. Got sodium here and potassium here. Sodium has a higher first ionization energy than potassium because potassium has much more shielding than sodium has. So it doesn't experience as high attraction from the nucleus as Next question. The table shows first three ionization energies for B and K. Suggest why compounds containing B3 plus ions are unlikely to exist. As you can see, boron is in group 3, which means if it was an ion 3 plus, it would have to produce 3 electrons. 1, 2, 3. And this tells us that a lot of energy would be needed for B3 ions to exist. Now what we gotta do is write an equation to represent the second ionization energy of potassium. So as I said before, you write it in products with gaseous state, like this, and then left hand side just to balance the equation, so with 1 plus. And state how first three ionization energy of calcium would differ from those of potassium. So we've got the potassium ionization energies here, and now as we look at calcium, which is right here, we can see that the first ionization energy of calcium would have a higher first ionization energy because it has more attraction from the nucleus, it has more protons. And the second ionization energy of calcium would be lower than that of potassium, because potassium, by the time of a second ionization energy, potassium would have a full shell, less shielding, and calcium would just lose 1 electron. Therefore, we say the second would be lower, because potassium has less shielding. And the third ionization energy for calcium would be higher. They would have the same amount of shielding. However, calcium is in group 2, therefore it would have more protons, so again it would have more attraction from the nucleus. Next question says the equation below shows the removal of 2 electrons from an element X. This is the equation, and where X is calcium, magnesium or sodium. The table below shows the energy required to remove 2 electrons from each of these elements, calcium, magnesium and sodium. Explain in terms of electronic structures of the atoms concerned why the energy required to remove 2 electrons from calcium is less than that for magnesium. As you can see, calcium is right here and magnesium is here. The electronic structure of calcium is 2, 8, 8, 2, whereas the one for magnesium is 2, 8, 2. From this you can see clearly that magnesium has 1 less shell than calcium, therefore it has less shielding. And a smaller ionization energy. Calcium has more shielding and magnesium has less shielding. Okay, so now we've got to explain in terms of electronic structures of the atoms concerned why the energy required to remove 2 electrons from sodium is greater than for magnesium. Sodium we've got here and magnesium we've got here. This time, sodium has a bigger number than magnesium. This is because magnesium, as we can set, is 282 and sodium is 281. This means sodium is closer to the nucleus. It has a greater attraction than magnesium. That's why its ionization energies after to remove 2 electrons would be higher than that for magnesium. It's very easy to confuse all of this, but I'm sure if you look at my blog post titled Electronic Structure and Ionization Energies, which I linked in the description box below, you will start to get it. Now what we've got to do is use electrons in boxes to write the electronic configuration of phosphorus. And we got to see how many electrons phosphorus has first. So our phosphorus is in group 5 and it has 15 electrons. So let's draw the boxes first. 1s, 2s, 2p, 3s, 3p. There are always 2 electrons in one box, so 2, 4. We start writing with 1 in each first. 7, 8, 9, 10, 11, 12, 13, 14, 15. You always write 1 in each box first, and then write the next ones if you have to. But we already got 15 electrons here, so we don't have to worry about this. I'm going to draw the boxes first. Now what we've got is magnesium. However, it's 2+. That means it lost 2 electrons. So if magnesium has 12 electrons and it lost 2, we've got 10 electrons for magnesium. As before, you write electrons in the boxes. So 4 electrons, 5, 6, 7, 8, 9, 10. And that's it. Next, write the electronic configuration in terms of subshells for a chromium atom. What we've got to check first is how many electrons does chromium have. So chromium is right here. It has 24 electrons. We can write that down so we remember. And it goes like this. 1 S2, because 2 electrons, remember. 2 S2, 2 electrons. 2p6, 6 electrons, so we already got 10, but we need 24. So we keep going. 3s2, 12 electrons. 3p6, 18. And this is where the difficult part comes in. So if you're not sure what to do next, I recommend just write in the boxes. And now we've got our big box, 1, 2, 3, 4, 5, and a small one. As you probably know, you should always fill the small one first. We've got 18 electrons here, and we need 24, so we've got 6 left. So we write one here. We would usually write the second one right next to it. However, this would leave us with this, and the atom will be much more stable if it has half full shell. So what we do is put that electron here and don't put it here. So instead of this, we have this with just 1 electron. So now we can finish off writing this, just 3d5, 4, 1. The last question says the first 4 ionization energies for an element are these. The element belongs to group, and we can see the biggest jump is right here. So it has to belong to group 2, because if it left, for example this one, first ionization energy is small, second ionization energy is small, and the third one would be the greatest, because it will have already less shield than group 2 in the periodic table, because there is a large jump between the second and third ionization energies. See, between second and third. Okay, these were all of the questions I've prepared. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.